I'm Chief Meteorologist Mark Weinberg. This is Rick DeLuca. Bryce Jones will be joining us. Come over here for a second, Bryce. We are going to be discussing our winter weather outlook, and we changed Bryce's schedule a little bit today because he did do some of the lifting in this, and will be joining us. Bryce, the thing that you're going to be discussing is snow amounts. So we'll see you in a couple of minutes. We don't have a mic for you yet. Dude, I don't even get a pump.
Is that?
Oh, I didn't know if you didn't even offer one.
Well,
Dude,
just get a little quick pound. Come on, guy.
So Bryce will be joining us. The point of this video is the winter forecast of 2025, 2026. Rick DeLuca is on Facebook. Obviously, I am. And Bryce Jones is as well. If you guys don't follow them, please do. Secondly, and I think this is one of the most important things whenever we start a video, is I always ask you guys to share it. So let's just say you have 100 people following you on my page right now. There's 250 people. That'll mean 25,000 people would be alerted. They may want to come in on the live. They may want to see how much snow am I going to get? Is it going to be cold? Is it going to be warmer? And even more importantly, I think the reasoning behind this is what makes this live kind of fun. What we can show on TV, Rick, is the result.
Yeah.
It's
condensed down. Like, if you like bourbon, it's distilled down to just a tiny bit. This gives us a lot more breathing room to go into so much more detail. And not only that, but you can kind of see the process of how we go about building the vlogs.
So if you, again, are just joining us, please share the video. Thumbs up if you guys enjoy these. Hearts on the screen if you're on Facebook. And you can join us on YouTube, as well as we are also on the WDRB.com website. So let's get this thing started. Rick, one of the things that people probably see on the daily from us is these winter forecasts or a spring or a summer or just outlooks. You rarely get to go behind the scenes with us and see some of the nuts and bolts on what goes into some of this. And I'm asked a lot of times, I assume you are as well, just what it's going to be like. And I say, well, we kind of deal in probabilities. And that's one of the things you're going to hear going through this is why probability.
Right.
Sometimes it's like a slam dunk on what's going to happen, but you're going to see here, sometimes there's conflicting signals.
And also want to mention that most people just want a simple yes or no.
Right.
And it's hard to describe things when it comes to probabilities, because if I say it's a 50% chance of something, you're like, well, it can go either way. And that's the honest truth behind some of this equal chance probability, is that it can swing to either side or the other. And I know for some people, it's not the forecast they may want to hear, but sometimes that's just kind of what you get in certain scenarios based on some of the indicators. And we have a lot of indicators that we look at, but there is not one more important than the current state of the ENSO.
And the ENSO is El Nino or the La Nina. And that is where we're going to start this discussion.
And also the neutral. So you have 3 phases you can be in.
So when we look at this, Rick, we're going to start off here by looking at the state of our El Nino. And this is something that is incredibly important for us, is where we stand in the El Nino. Bryce, I know you're in the control room in there right now. Can you just let Sean know that when we're hitting 6 right now, it's pulling our main weather system. So we just have to make sure in that 2 box that we can get 6 in there. So let me just check one more time. Yeah. So we're going to just have a pause here for a moment as we get that figured out. But Rick, the El Nino and the La Nina, I want to kind of start with a description of what these are.
Yeah. So we're talking about ocean temperatures, not air temperatures.
And that's not like in the Gulf. That's not in the Atlantic.
No.
This is a very specific area on the globe.
This is the equatorial Eastern Pacific. This is where teleconnections come into play.
And teleconnections mean this can cause that.
Right. And this is important because El Nino, so I don't know if you know this, but El Nino came up, I think it was the early 1900s. Fishermen off the coast of South America. This is what I found out. They were fishing and they realized around Christmas sometimes the water would be warmer. So since it's around Christmas, they just said El Nino, and that's kind of what they faced. And then other scientists along the way realized, okay, well, there's also cooling in that area, or sometimes it can be neutral. So that's how we came about the 3 separate phases for El Nino. We can have La Nina, which is
colder,
the cooling, El Nino, which is the warming, and then neutral, where it's not cool or normal or cold. It's just basically at even.
And then this extends over such a large portion of the equator west of Ecuador that it then affects global weather patterns. And that's what Rick mentioned with teleconnections. X can mean Y. And these are things that are really, really important. is why. Why then does the El Nino or La Nina matter? And it's because it dictates the jet stream in North America, which become critically important and how things work. And you can see, you know, like later this week, we're talking about temperatures are going to get really cold. And that's kind of how we're going to be talking about this, is what does this style of weather pattern, El Nino, La Nina, there's things that we call the Pacific Decadal Oscillation, or PDO. We really like when we have a warm blob in the Atlantic. We really find that to be something that's very, very important. Bryce, can you just let me know, is that going to be able to stick when we hit the button, or is that not going to? Does Sean know? So if we change and click the button onto something else, will it stay? If not, I can just leave it in this mode and not really come off of it much. So this is a graphic, Rick, that shows what I would refer to as the condition state of where we are in the El Nino or the La Nina. And what I'm going to do here is show you a couple of pieces of information here. So Rick, I'm going to draw a line to the 0. The 0 is what you mentioned, neutral.
Right.
The upside would be El Nino, warming. The bottom side would be La Nina. From here, you will notice that on the bottom of the screen, you see letters. So you see OND, October, November, December. You see DJF, December, January, February. And the DJF period I'm going to draw a line to is right here. So Rick, now that we kind of get a sense of what this means phase-wise, where are we going for winter?
So basically, what you should already be reading off this graph is the fact that we are on the south side of that line. So we already have a La Nina present, which is going to be the cooling of the equatorial waters. And it does show we stay in La Nina for at least much of the actual winter months themselves, and then start to tail off toward neutral. And just so you know, compared to last winter, we had neutral conditions and then actually went into a weak La Nina.
And that one produced the big hit.
And that produced a big hit. But I want to say the most important word is weak. We are not seeing strong signals either way for El Nino, La Nina, only a couple degrees on either side. So this is not something that's a very strong, powerful signal. Is it the most useful one for meteorologists when it comes to winter forecasting?
Valuable.
Absolutely. But it's also worth noting that it's not the strongest La Nina that we've ever seen either. And what was it last year?
And you can
27.6 inches of snow last year with that developing weak La Nina. So that's just something to consider.
And you could see here, kind of to Rick's point, the computer model here, and this is what we call a spaghetti plot. It's very similar to what you see on TV during tropics. The coldest model shows it at 1.25 colder than normal. The statistical mean takes it at around a half a degree. So we're not looking at a monumental La Nina or a monumental El Nino. So understanding this, Rick, now you can see at least the state of one of the more important pieces of the winter element. We know that as we start to move towards spring, the influence may be weakening, which again, you could say last year in a neutral, we got a hit. So from here, we're going to start to look at what we refer to as our analogs. And this is something that I think is quite interesting. So analogs is kind of one of my things that I enjoy. Analogs from a weather model perspective, I hate. And I hate analogs from weather model perspective because analogs try to look at how does what we have compared to years in the past. Meaning if we find years with the same El Nino or La Nina state, what happened in those years?
Right.
Because I think that's really important. Now, if you use that with weather modeling, well, you could say that the GFS computer model is showing a monumental storm 5 days out. What does that compare to? Well, that compares to 1974. Here's the problem. What you're comparing it to is a computer model that has fallacies and inaccuracies built into it and trying to compare something that's erroneous to something that actually happened in the past. What we're talking about is we know there's a La Nina, and we can then apply this backwards. So when we looked at the years, 1954, 1955 had a weak La Nina. And you can see on the top of the screen here, all of the analogs that we determined that had similar El Nino, La Nina conditions. In this case, a weak La Nina, and what years those were. I heard somebody in a YouTube video comparing this year to 1989. The oddity of that is 1989 is one of the strongest La Niñas on record. That's actually the legend of La Niñas, whereas 1983 is kind of one of the legends of El Niños. So we purposefully did not include those, Rick. So when we look at the signal here, one of the things that we note out of this particular graphic, Rick, is warmer, colder than normal. And this one is the DJF, the traditional winter months. So what you see.
And what you see, and I know some people, it's like, you meteorologists make things so confusing. We have astronomical seasons, and then we have meteorological seasons. So
I think meteorological is easier.
I'm with you on that one. So that is December, January, and February months. So that 3-block month, okay? So we're looking at where you see the legend at the bottom, the yellows, the oranges, the reds. That means temperatures above average, and vice versa. The greens, the blue shades, those are temperatures below average. What you see on this map, especially biasing toward the northwestern part of our area, would be a low probability of below average temperatures. Again, this is for December, January, and February, below average temperatures. And that's just our analog taking all of those weak La Nina years and saying, okay, well, history tends to repeat itself. So this is basically a tool that allows us to sift through history and see which ones, I mean, it's kind of cool. Yeah, my eyes light up, but like it's cool to see how everything is connected and how you can use all this information, this database from the past, and kind of start working through it and figuring out how this winter may apply.
And one of the things you note here, based on what Rick said, is there's darker blues in the high plains.
Oh, yeah.
So when we talk about what La Nina connection is, the connection in our area is skewing towards near to slightly below. But you can see in the high plains, Montana, North Dakota, South Dakota,
they get rocked.
into Minnesota, it is a massive signal for colder than normal. So from here, we're going to show you a couple of other things in the similar perspective. This is going to now take December out. So what this means is now we're looking at January, February. So if it was skewing much colder in the northern high plains towards southern Indiana, showing that skew, what you notice is it's not as pronounced in January and February. And what does that mean for December, Rick? It means that December is skewing colder in these weak La Nina years.
And that may not be the case when it comes to January, February. I'm not saying with certainty.
It's just not a massive statistical correlation.
Exactly. But I mean, you see there's those yellows, and that's just Kentucky and Indiana too. So that would say, based on analogs, again, which is just past La Ninas that are weak, that we would see warmer than average temperatures throughout the Ohio Valley. I mean, that extends all the way up through the Northeast, in fact.
And when you look at the actual numerical value of that, we're talking a half a degree.
Right. It's not significant, but it's noteworthy.
Agreed.
And that's why we kind of take all these months. So 5 months. What is it? November, December, January, February, March.
When we now pack it all together, we put from now all the way through March, put it in a blender, mix it all up, and this is what it shows.
And it shows, again, it's not a pronounced signal, but what you pointed out, the Upper Rockies shows that much colder. And then once again, we are on the edge of below normal temperatures. And this is the whole block. Traditionally does not include the core of December, January, February. It extends on a little bit. And that's something we're going to talk about more in this video.
Yes, and Bryce is here sitting because Bryce is going to talk a little bit about this.
Because we kind of came up with something that we found extremely interesting. But it's you'll know why we include those 2 months when we get into the snow portion. This is specifically just about the temperature.
And we're piecing the puzzle together as we start to talk about how this thing is going to unfold. So from here, we're going to look at precipitation anomalies. During weak La Ninas, was it in December, January, February extremely wet? Was it extremely dry? Rick, there's a signal here. Interestingly enough, in the moderate and the high La Ninas, it is a slam dunk in the Ohio Valley to be wetter than normal. The weaker show wetter than normal, but they don't show it as pronounced.
No, I mean we've seen La Nina is known for getting more precipitation than average. I mean, that's just part of the forecast. And when even if you Google something like this, there are typical jet patterns that set up every single time like clockwork. So to have wetter than normal conditions is something we're used to seeing. This really, I mean, it almost says you could go either way. or just be a little bit wetter.
And that's the DJFs, which are the traditional considered winter months.
Which doesn't always mean snow either. I think a lot of
Here's
people
the thing:
forget.
it's not showing dry, and it's not showing. The fact that it's showing skewing slightly wet.
Right.
Remember, we average 3 to 4 inches of liquid precipitation or so.
Whether it's snow, whether it's
near
rain.
normal is a big deal. It's a big deal. It's actually quite a bit of precip, and the fact that I'm going to come back to this. We'll spend a lot of time on this. But Rick, the fact that the much colder is just to our north and the warmer lies just to our south kind of tells us some things about where that jet stream may locate itself, which is the energetic part.
The energetic part, it's called the baroclinic zone, which is where you see two air masses clash. And along that clash is where storms like to ride. I mean, that is basically like it's the highway for storms. So that is very important for us because if there's that clash, then we're going to be in a pattern that's usually pretty active. We call it northwesterly flow. And that's something that sets up, and usually time and time again, you get storm opportunities. Without an opportunity, you can't get any sort of precipitation. So at least we have those.
And to this, if you've followed weather for any period of time, you know that the El Niños, so in the 1980s, when I was growing up, in the 1980s, there was this talk that California was going to fall off the western part of the U.S. because it was raining so much. The waves were hitting California coast, and then there were buildings that we would see that actually homes that were collapsing into the ocean. But if you know that period, you know that period was well known for having so many El Niños. Look at the opposite in California during La Niñas. The signal for drier than normal through South Texas into Florida is massive. It's not small.
Complete
it's
opposite.
Super dry by several inches during the month of January and February. And from here, we're going to look at the November to March period. Rick, this correlates to what you showed earlier. You showed earlier that the temperature contrast was massively colder than normal along the northern tier of the U.S. And this graphic shows you, again, you might be able to argue a low signal towards wetter than normal over the next 3 months, but it's not a large signal.
No, but it shows up. It's there. You can't ignore it, but it's not something that really jumps off the page. And it's like, oh, well, take that one all the way to the bank. It's just something that you need to consider.
And I think it means that we're probably not going into drought this winter.
Oh, yeah, I think that's a very safe thing to say.
So that's an important thing to note here. So from here, what we're going to start to do is look, Rick, this is one of the things that we really like to look at when we talk about seasonals. So these are sea surface temperature anomalies, and it kind of explain what we're seeing here. And you can see this is off the West Coast. This is into the Pacific Ocean and why you should care.
Right. And so many people, just think it's all about air temperature. And we have the North Atlantic Oscillation, the Arctic Oscillation, but you also have to look at ocean temperature. So these are sea surface temperatures in the Pacific. Now, we know we have the warming for the La Nina, but there's an interesting feature south of Alaska.
Yes.
You see that area of blue? That's known as the blob. Now, in 2013, this was a warm blob, and unfortunately, it really changed the ecosystem there. It began in 2013, late, lasted through 2014, and it's something that's actually been recently verified, studied, so it is kind of relatively new when it comes to meteorology, but it's such a pronounced feature that when you have so much storm action over the south part of Alaska, it causes upwelling. So storminess churns up the ocean, down layers, you have colder water below, that gets pulled to the surface. So now that blob is not warm, it is cold. And that's going to be a key component when it comes to how the jet reacts.
100%. And I saw people talking about the PDO being massively warmer. And look, we agree. The almost whole of the Pacific Ocean is massively warmer. But this is the problem with the alphabet soup sometimes of picking these indices or these values, is it doesn't take into account some of the smaller details. We see this with severe weather forecasting. So often they're wrong because they just simply don't look at the subtle details. And I think Rick picks up on a really important thing. We all agree the Pacific Ocean is warmer than normal. And if the whole thing, including southern Alaska, was warmer than normal, this would almost be a slam dunk for a traditional La Nina pattern. However, in this particular instance, there's the upwelling that's occurred in the south of Alaska, and that goes as far south as Portland and west of San Francisco. And this
can't be
introduces
ignored.
some
Complexity and also competing kind of factors here. So if we had cold air there, we would not have that strong ridging, which we would have if there was a lot of warm ocean temperatures.
If that ocean temperature was warm right through Alaska, it would push the jet stream north, which then kind of brings this to what does a weak La Nina jet stream look like. And Rick, to your point, that high that is sitting over the Pacific, it would push the jet stream further north, reinforcing a La Nina pattern if that water was warm south of Alaska.
If
the reality is that's not. But
Right.
you can see here, and Rick explained, this is kind of a jet stream style pattern for what is common during weak La Ninas.
Right. So we have two jets. There's also a Pacific jet, but the one you see on the map, which is more important, is the polar jet. And that's the one that supplies the cold air. You can't have a winter storm with just moisture or cold. You got to have the two of those elements together.
Exactly.
So that's the one that supplies the cold. The Pacific is the one that supplies the moisture. It does equal wetter than average conditions in the Pacific Northwest. And hey, I think you mentioned this.
It's odd, right? It's odd that it shows drier along the southern tier of the U.S. into California. Interesting, isn't it? But the analogs show it. So you kind of
really
start
do.
to see when we're not just, I'm not going to say that winter forecasting is the most accurate thing we do.
No.
We are fully transparent and upfront that this may be the least accurate
That's
thing we do.
100% true.
But what we try to do, because the demand is there, is looking at the data, looking at the signals, and what do past years what have they done? And so the reality here is we will likely be in the clash zone.
Right. And you have to have realistic expectations when it comes to winter forecasting. Again, it's highly variable, especially when we have something that we have weak indicators and then other elements coming into play, like the blob. We really need to consider all of them, but really there's no dominant feature with this upcoming 2025-26 winter season. But what you do see is, like you said, an active jet and a weather than average pattern,
and the warmer even shows up, which we saw in the analogs
which we
in
saw.
the southeast.
So we're really going to be in between those two air masses, and it's going to come down to phasing.
You bet.
If we can get the piece of energy with the cold air to phase, basically two areas of low pressure coming together at the right time to get us that opportunity for some cold to be with moisture, then we would get some snow, Mark.
And we will see when Bryce comes in, this absolutely happens in La Nina years. It doesn't happen in all weak La Nina years, but it does happen in weak La Nina years. Yeah, and some of
phasing
them
is huge when it comes to these
full-on
storms.
strikes. So, Rick, let's go through the winter forecast for temperatures, which has been the portion of this that you've spent a significant amount of time on.
Well, I'm going to say it's going to be cold this winter, and you're going to say, thanks a lot, Captain Obvious. Appreciate that. But that's truly what the forecast is. It's going to be near normal to slightly below normal. And that's just because of that blob. Basically, it's going to compete with the jet, and the pattern's not going to be as predictable because there's some variances with the actual ocean temperature south of Alaska. So the traditional jet that goes over through Alaska down to the Pacific Northwest may change a little bit, and it may vary in where it's positioned. We're going to keep an eye on that one carefully, but for now we're going with near normal to slightly below normal temperatures. And you're like, okay, well, what's normal? The coldest high that we have is 34 in terms of average. That's going to be your basement. That's as low as we go with averages. But, you know, there's going to be times where it gets colder.
Of course, last winter was an example where temperatures were not that far off from normal, but you remember January.
It was frigid. And then we also have already had this year sudden stratospheric warming,
events,
which leads to disruptions of the polar vortex, and that gives us cold. We had one taste already. There's another one coming down for Thanksgiving, just kind of giving you a feel of what winter can be. And it certainly seems like that's how we're starting. So it would be silly to not assume that that's going to continue here for the next month or so.
So from here, this is where we're going to go ahead in a moment and bring Bryce in. So Bryce is going to come in here and spend some time talking with us about snow. I want to mention here that precipitation. Traditionally, when we look at La Ninas, even if they're weak La Ninas, we traditionally see wetter than normal conditions. The strong La Ninas are massive in their wetter than normal. The weak La Niñas are not as massive, but I do think that we're talking about a type of pattern here that would bring the slightly wetter than normal. And then number two, I think that it's fair to say that we're very likely to be seeing near to slightly below normal. But I think the devil's in the details when we go through all of this. And I think this is partially what you're really going to enjoy. So from here, I've promised you that I was going to bring Bryce Jones in to discuss parts of this. And Bryce, the thing that you and I spent a lot of time looking at, and we were sitting in the weather office one day. So Rick DeLuca and I were talking a little bit about, hey, it's time to start to get the winter forecast going along. And I think Bryce said, hey, Rick said that you were going to get the analog data to us. And I was like, he did say that because I said that to him. So I was like, Bryce, I'll get that going in the next couple of days. And then I was like, you know what? Let me just grab one piece.
Yeah.
And so then we started with one piece and we're like, oh,
that's interesting.
and then we went to another. And then Bryce is like, hey, well, let's include more months or less months.
Right.
And then this is where we tangented. We kind of went off the beaten path of what we normally do in these. And Bryce, we were like, let's look at snow for each individual year. And then we wanted to take a look at spring.
Yeah. So as Mark and Rick were mentioning, we're in a weak La Nina. So as I talked about earlier, if you're just joining us, we look at every single year in the past that has had a very similar weak La Nina to what we're watching. And we went back and we looked at all the data, and we're looking at how much snow has fallen in each one of those patterns that are lining up to look exactly like the one we're about to have. And it's not gospel, but it can kind of give us a really good idea, as Rick DeLuca mentioned earlier, Mark. History can repeat itself in some ways.
So when we start to now speak to versus average, what does Louisville see for snow a year? 13.4 inches. Yep. Rick noted that last year was 27, with a huge portion of that coming during January, where we got during one snow was enough to put us in the top 10 snowiest Januaries on record from one system. And I know snow lovers were loving it. The snow not lovers were like, oh, it's so beautiful. Okay, it's brown. Get it out of here now.
And it took forever. It took forever to get rid of because it was cold for so long.
Well, I don't really remember that portion because I think I was on vacation during that.
He's like, yeah, it was like 88 and sunny on the beach.
It was my birthday. I had to get away from my birthday. It was so from here, we compiled some interesting data. And Rick, Bryce, this is going to be for December, January, and February. And this is going to be the 12 analogs that we found with weak La Niñas.
Right.
And one of the things you note is we broke this down into above normal, near normal, below normal. And what you're going to see here, as Bryce describes, is there's a lot of each.
Yeah, exactly. So these are the 3 months of winter. Now, I know winter doesn't start until late December, technically, but meteorological winter starts December 1, and it goes all the way to the very end of February. It makes it a lot easier for us to track records and the whole 9 yards. So when we look at winter, we're talking December, January, February, what you typically would think. So on the left side of your screen, years 1964, 1971, 1984, and 2016. And a bunch of you guys probably remember some of these years.
Yes.
Those winter months, this does not include November. This does not include anything after February. Those 3 months saw the highest amounts. And these are, again, all the same pattern that we're about to go in. 1964 was the jackpot. Saw almost 30 inches of snow for the entire year, which is another 4 inches on top of what we saw last year.
So I also found something really interesting when I was looking at this. When we started to talk about this, 1964 had nearly 30 inches, and then 2017 and 1983 had 5 and 2. Bryce, what I think is most interesting about this is a lot of these years fall not that far off from normal.
Yep.
Basically, of the 12 that we have listed here, 1954 to 1971, which would be all but 8 of them, 66% saw within 3 or 4 inches of normal.
Yeah, and as we talked about,
the extremes in the winter months are not showing off as much.
Right, exactly. So if you look strictly based off these months, you'd think, okay, snow's probably going to be around normal. So, because I mean, we're talking about a huge range from only 2.7 for the entire 3-month period back in 2017, all the way up to almost 30 inches in 1964. But we averaged 13.4. So you go around average, and as Mark mentioned, that's most of these years here. But again, this is strictly for December, January, and February. And
Which
typically we get most of our snow during those 3 months, and we get a lot of it during January.
we do get spring snows.
Exactly.
though.
And that's kind of one of the main things that we noticed and that we found most interesting that I really haven't heard anybody else talking about, to be honest, is the fact that when you look at all the previous week La Niñas that we've had, again, just like this year, 50% of them, 6 of the 12 in history that we've recorded, have had spring snow.
And people are going to remember this one. I remember it vividly.
Yeah.
Was the Monster 17. So Monster 17, this is the snow that came in March. I have some snow lovers on my page that will say, if it doesn't fall in the winter months, that's not snow because it melts off fast.
Right.
But 2017 produced 22 inches of snow in March in Bardstown. Where I live, I measured 18 inches of snow at my house. It wasn't snowing on that one. It was like puking snow. It was coming down so hard. But what we did see here is that spring snows, they show up sometime in these weaker La Nina years. Now, you might be saying, well, Mark, I'm looking at the right, and I also see a bunch of them that show nothing.
Right.
So it kind of in this area was more of extremes.
Yeah. Yeah. There were a bunch of years where all of a sudden it was like, it's the middle of March and we just got an extra 8 inches of snow. Like, that doesn't seem right. But we've noticed that when we looked into the data and we did our research with this, a lot with this weak La Nina pattern, that was the case, to where a lot of December, the early months in winter were they were a little quiet in terms of snow. We weren't talking about a lot. We may have a few quick hitters here, there, a few clipper systems coming in and out of Canada. But when we're talking about some like legit snow, a lot of these weak La Niñas started off pretty slow through December, and then it was almost marked the second half of quote-unquote winter and heading into the first half of spring when we got the bulk of our snowfall. And like you said, just a few years ago, back in 2017, we saw 13 inches of snow in March.
In a weak La Nina. So these are things that are important to note. I will say that if you look at this, a vast majorities are 0. 6 of the 12 are 0. 2000 is 0.2. 1983, which was coming out of a massive El Nino in 82-83, that one showed low amounts. 74 is a year, obviously, that goes down in history, coming off the massive tornado outbreak. And that's the insanity of that, is the 1974 tornado outbreak, which I think is obviously something etched in everybody's mind. But in the spring of 1974, we saw 10 inches of snow. That was followed by the 1974 tornado outbreak. That's the insanity of that year. And then 2017 is another one that showed, again, some sizable spring snow. So let's then piece the whole thing together in terms of our snow forecast. Again, I will say this. Seasonal forecasts are probably not the most accurate thing that we do. We do them partially because you want them. If it was up to me, would we be putting seasonal forecasts together? My answer is no. And someone might be able to argue that it's probably because it's a little more extreme-ish. It may be a little, you could argue there could be sensationalism in some of this because the science is not as great in seasonals. But people love them.
Which is why you're not going to see us come on here and be like, Louisville, you're going to get 16.5 inches of snow this year, because that would be, first of all, that'd be wrong, because the odds of us getting exactly 16.5 inches of snow is 1 in a million. So it's like, from this point out, we're giving you kind of like an idea more compared to what we normally get. And that's the good thing with all of the factors that Rick and Mark and I have been mentioning. All of these kind of go in together and help give us an idea. La Nina, you're typically going to be above normal for precip. But is that precip snow? Or is it rain? I mean, if we're 33 degrees all winter long, every time we get a good storm system in here, then newsflash, we're not going to get any snow out of it. So a lot of that's going to come down to where the systems come from. We get what's called Alberta clippers a lot coming out of Canada that come by, and literally they're called clippers for a reason. They clip our area, and it puts down, it's one of those where it puts down like maybe 1 inch to 4 inches of snow at most, and then it's gone. Like that. But when you're talking about your big snows, Mark, you're talking about a different storm track.
And so when we started to piece this all together, the snow is the one that everybody wants.
Yeah,
we have seen that when we average this out, that near normal was the most likely scenario, which is 13.4 inches of snow. We also found that there was potential for some extremes on either side of this, where some of the numbers were higher, some of the numbers were lower. And also we found quite interesting, and Sean, in a moment, just a question for you. Am I going to be able to pull the camera full or graphics full with the buttons here, or is that something you could help me with if I need it? Okay, I can do that. Okay, so let's bring our cameras full here real quickly. So we found that 50% of La Niñas did have snow in the spring, which I think is interesting.
It is interesting.
We found 2 of those had significant snows in the spring and the weak La Niñas, which produced a massive number.
Right.
So these are interesting things, and I'll just show you it full so you can get that. And we're going to bring Rick back in here before we open this up to questions, because we have, I know a lot, our forecast and our winter forecast is something that I know a lot of people love and enjoy, but I also think that there are people that are curious about asking questions. What does it mean for me? Can you clarify on the forecast? What are we talking about? So since Rick was in the temperature department, Rick is going to join us, and he'll be talking specifically about when we're talking about temperatures. I'll spend some time, if you're curious, about precipitation amounts and snow, which I assume is going to be a monumental portion of this forecast, is what Bryce will be discussing.
And that's one thing I want to mention. I think the most obvious question that I've seen so far, which, by the way, now's your opportunity to ask. While we were talking, the most obvious question is a white Christmas possible or not? And that kind of goes into all 3 of what we're about to talk about, because you have to have cold enough air, you have to have high enough precip, and those 2 things combine to bring in snow. So that's all going to come down.
And I'm going to say one thing on that is that statistically a white Christmas in our area happens 5% of the time.
Yeah.
So what that means is if you live here, 95% of Christmases are not white Christmases. So you can understand that. So I'm going to bring Rick in here, and this one's going to be a temperature question. So Karen Ray is saying, is a stratospheric warming caused by a disruption of the polar vortex? That's something, Rick, that we talk about what's happening now, and it does seem like it's a kind of cool question to answer, but it's almost the opposite.
It's exactly the opposite, actually. The sudden stratospheric warming is what we see first. So there are 5 layers to the atmosphere. Troposphere, that's where we live.
See if he gets all these right.
Stratosphere. Oh man, you're putting me on the spot. Troposphere, stratosphere, mesosphere,
Correct.
thermosphere,
He's right. He's right.
and
I'll give you a hint.
ionosphere.
Your face
Is it
got red.
ionosphere?
Your face is red. Look at
that
he's
degree.
blushing. He is blushing. He did not expect a test.
See, I gotta- well, he's always testing me. He's always testing me. I was gonna stop at troposphere, but he's like, "All right, do it." And then what's beyond that? Exonosphere.
Then that you could argue is ionosphere.
Exonosphere, yeah.
that's
So there's another one in there.
So
I just
coming
had to
back
get all
to
my
the
spheres together here.
So that one layer of the atmosphere, we live in the troposphere. That's where the weather producing portion of the atmosphere. The polar vortex lives in the troposphere, but above the troposphere is the stratosphere. And when you get these warming events, Rick, this is recent science, but it does show something happening in our part of the world.
Right. It actually disrupts the polar vortex. Now, polar vortex, I think everyone's like, oh, it's the cool word to say. And I always feel like in the past several years where like news will start to latch on to some of these weather terms that we've had for years and years. And this is an event, sudden stratospheric warming, which means warm air aloft, and that disrupts the polar vortex, which means a chunk of that can break off, dip south, and move our way. The polar vortex is always there.
Literally
Always
every
there.
single
It's there
day.
right now.
So if somebody says is there going to be a polar vortex? Yes, there's always a polar vortex.
I see like commercials like polar vortex is coming with that, and I'm like,
So sudden stratospheric warming creates a disruption in the polar vortex. What that can mean is it can segment, it can break apart,
it just kind of
and
wobbles.
portion of that or the polar vortex itself can shift to our portion of the globe. The polar vortex is the gatekeeper for the really cold air in the hemispheres, and when the polar vortex shifts towards our part of the globe, we turn colder. So it's a great question here.
when it's stable, it stays there. When it's unstable, it comes down.
Bryce, I'm going to put this one to you. This is coming from Gina. Gina is talking about snow and asking about Thanksgiving. So I'm going to go ahead and say that this question probably comes from a little bit of what happened last week. So last week, people started posting snow maps for Thanksgiving and Black Friday showing snow amounts. And some posted amounts that were over 8 inches within our area.
Yeah.
And I saw somebody that even showed a storm track and showed literally snow over our area for late this week. So Bryce, looking at the data, how much snow are we talking about for Thanksgiving and Black Friday?
Let's see. Oh, it's 0. That's right. Yeah, it's
I
0.
mean, surely that's not showing up in every piece of data that it's 0, right?
Every single one.
I mean, there's going to be a couple of clouds maybe, right?
It's probably not.
It's going to be sunny, and people were forecasting 8 to 12 inches of snow on Thanksgiving and Black Friday. That's why we say when you see that, you crumple it into a ball and you throw it into the trash can. And then second, you block or unfollow that person because you know that they're playing around with your emotions. They think it's fun to scare you. Maybe your family was like, I'm going to come for Thanksgiving. Well, I saw this guy that says you're going to get 12 inches of snow. Maybe I'm not coming. It's not funny. It's not, because it can affect people. So bread and milk, is Shelby saying, okay, yeah, the bread and milk's already going to be gone. Not on this one. So this is an interesting one. David is asking about the volcano blowing that ash. Is that an extra variable? So David, that is a brilliant question.
I just saw that today. I just saw that. I didn't even know that had happened.
So that
until
one
today.
And you know, by the way, that was a shelf volcano. That was not a caldera volcano. So this was a very unique volcano eruption. What you're used to seeing is the cone that goes up, and then the volcano explodes. So the shelf volcano that exploded in, I believe it was Philippines, was a shelf, and it has never in recorded history gone off. So that fired ash up to, by satellite data, 18 to 20 kilometers, which is about 9-10 miles up into the atmosphere. So if it's 9 or 10, it did not go into the stratosphere. That's important to note, because if it went into the stratosphere, it would stay around for a long time, and that can lead to colder than normal. That happened after Pinatubo. That in modern times is the most known of the cool winters following a volcano. But if you go beyond that, you guys know I talk about this one, Krakatoa. Oh yeah, Krakatoa was 1883. I don't know why, but I'm fascinated with these cataclysmic events, because part of me thinks if it happened before, it can happen again. So Krakatoa was cataclysmic. You could hear the explosion 5,000 miles away. 5,000 miles away. Krakatoa, the shockwave went around the globe, I believe 6 to 8 times. Krakatoa led to the what's referred to as the summer without a summer. It was cold year round. It caused massive crop failure and ultimately resulted in a large number of fatalities because it was the year without a summer. So Krakatoa and Pinatubo were so large that they affected things differently. But I thought that's a really good question from David here. Let's see. Somebody's asking, do we remember, does anybody remember the Ohio River that had frozen 77 and 78? We've all seen the pictures.
I think we've done a blog on that before.
You know, I was trying to think back. I remember what was the ENSO state? What
year was it?
1977 and 78 were the really cold winters. Was it La Nina or El Nino? We're going to see the state on that.
1977 was neutral.
A neutral year, which interestingly enough,
close to this year.
Last year was neutral.
It was last year, and 1978 was a weak El Nino.
So these weaker years, these are 2 weak years that have sometimes that possibility to produce extremes. And that's why we kind of mentioned that when we did this, that a strong El Nino or a strong La Nina, strong is a lot easier to predict than a weak.
Right.
So another question coming in here. Let's see. Carla's saying, if it's going to be real cold, we need a lot of snow. Just my opinion.
Yeah, I agree.
Here's a great question. This is coming from Kay. What does southern Indiana look like for winter snow amounts? Bryce, snow was on you. I'm going to give that one to you.
Yeah, so it kind of goes for our entire viewing area. We've seen a lot with these weak La Ninas that you have your extremes, you have your crazy ones, like back in, what was it, 64, I think, and then you have your not so crazy ones, where we've gotten 2 inches the entire year. So those extremes in both up and down are possible, but most data shows around normal, which is 13.4 inches of snow. And that's for Louisville, but you go up in Indiana, you could get a little bit more the further north you go up towards Seymour, even further up into Indy. Then you're talking probably a little bit more because you get some of that access to that cooler air. But most of our area is probably going to be around normal with extremes high or low.
And the reason we mention extremes is because it shows up in the data. And you have to remember, when we talk about an average, it's a statistical mean. So I'll just use as an example. Let's just say January 4th is 90 degrees and January 5th is 20 degrees. You average the two of those, 90 and 20 gives you 110 divided by 2 is 55. Now, if I told you that January 4th and 5th average 55 degrees, you'd be like, that makes no sense, buddy. It was 90 on one day and 20 on the other. So a statistical average flattens things.
It can be misleading sometimes.
Right. And what we will tell you is the statistical signals in this winter are not massively strong. And when we say near normal, we also lean on this idea that statistically there's not a major push towards a colder or wetter, or, for example, their statistical likelihood is not as large. I do think that we're probably going to see a higher probability of wetter than normal. I think that's the one thing in this all of that really shows. Right. And I think the other thing that we would all agree on statistically is we're probably going to be in the battleground a lot. And and as you guys know, getting a hit in a battleground year is something that really does happen.
Possible. We got another question in from Carla. Carla Shelton wants to know, what was it like in '94?
Yeah, so that was one of the bigger snows that we've had.
Monster.
So I think what she's asking is, what was the
ENSO
phase? The ENSO phase was neutral.
So, and that's one of the things that we have found a lot with this is the weak El Niños, the weak La Niñas, and the neutral years have the extremes. And you just called out 77 an extreme, 78 an extreme, and 94 the legend. 98's one of the other legends, which I'm curious on. That's one of the legendary snows that occurred in our area.
He was born.
Is that the year you're born?
Yeah.
I had already graduated. No, I was graduating.
I was born in October of '98. So.
Okay, so I'd already graduated then.
98
There's got to be a picture.
98 was El Nino.
Strong week, but it was an El Nino. 2004 is another year where we had a hit. A lot of people remember the pre-Christmas event. That one was my first year here in 04, my first winter to forecast. 2017 is an example of a weak La Nina that dropped a huge snow. And last year was a neutral that dropped quite a bit above normal. Yeah. So it is interesting that in these weak phase years that you can have these extremes. You're laughing about something. Tell me what you're laughing
at. I'm laughing at a couple of the comments.
No. Okay.
I have a question for you guys at home, and you guys too. What's your favorite Clipper name? Alberta Clipper?
Oh, no. This is definitely a Jude thing.
The Saskatchewan Screamer?
Oh. Jude uses all of them.
Or the Manitoba Mauler?
Jude uses all.
I like the Mauler, man.
You like the Mauler?
I'm going to go with you guys know I'm an OG, so I'm going to go with Alberta Clipper. Okay. What about you?
I just like Clipper because it covers all.
I think that I'm with you. I'm completely with you.
And not get the
completely with you.
We're talking about 3 different providences, so I was just trying to see, which one you buy.
Brian Shepard's asking, statistically, when does grass start growing again? Do you have an exact date? Area, average?
Freeze.
So you couldn't have any more frost freeze. The average last freeze is before Derby.
It's right before Derby.
So I always say don't plant before Derby.
So I'm gonna say you probably have normally until mid-April until the grass starts.
I just mowed for the last time. I don't want to see grass for a bit.
Oh man. Yeah, I'm in no rush.
It was the cat mow that just takes the leaves too. That was.
Yeah, I'm in no rush to get
I'm in no rush for that,
again.
but hope that helps, Brian.
So from here, guys, all the questions that you guys have asked, we appreciate everybody joining in here. I will say to you guys that we do these lives. It's something that we do a lot. We will be doing these frequently as we go into snow season, which we're in. Anytime we get a major potential for snow, we'll be doing these live a lot. When we have severe weather, we're going to be doing these lives a lot. So these are things that are going to become really important as we move forward, if you guys are interested. If you don't follow Bryce Jones or Rick DeLuca here on Facebook, follow them. I do lives a lot, but I'm not always here as well. So when I'm not here, that's going to give you a chance. You'll get alerts. So it's important. If you follow us, you'll get an alert when we go live. Lastly, I do want to mention one thing. Some have asked, is there any snow chance this weekend? The data, there's interesting pieces of data that show a little bit of a rain-snow mix this weekend. We'll spend a little bit more time on this, but it is what we call a warm advection storm, which will push warm air across the area and normally does not produce a significant amount of snow. So a couple things I'll note before we end the video. Number one, if you missed the video or you're just joining in now, Bryce, let's give one last recap. You give a recap, DeLuca, on temperatures, and Bryce give one recap on the snow before we end the video.
All right. take-home message. Temperatures will be near normal to slightly below normal. Normal's 34. So yes, this winter does have the probability of being colder than average. A cold winter. Coming out and saying that, but that's what it's going to be. You're not expecting temperatures to be way above average, which gives us the opportunity, Bryce, for more storm systems. So that's your department.
Yeah, and we talked about kind of being in this weird like battleground area where you know in Florida it's almost like guarantee you're dry, and then you go further north, you're guaranteed you're going to be wetter than normal. We're kind of in the middle. But I do think we lean more wet than normal. But again, as Rick mentioned, you also have to get the cold air in here at the same time. So based on the snow totals from the past week La Niñas that we've had, we're probably going to be around normal for snowfall, which is around 13.5 inches. But again, there's a lot of highs and a lot of really low lows. So those extremes are also possible. But I will say, and I will note, if we're going to throw a dart at anything, I would say that there's I wouldn't say a great, but at least a decent chance of seeing a spring snow this year once we get into March.
Those things don't last very long, but any snow in this area is highly impactful. I always joke about this. Why do we have so many problems on the road when it rains or when it snows? And I always say because we can't drive on the rain. When it rains here, there's a massive number of accidents. If you get snow flurries, it goes insane. So we appreciate you guys joining us in here. From the WDRB weather team, we hope you guys enjoyed our winter forecast. We'll be showing it on WDRB News at 10, WDRB News at 11. You'll be on WDRB News at midday tomorrow. Jude Redfield will be showing it tomorrow morning. You'll get a chance to see that again. Second, this is a really important week for family and friends. And from the WDRB weather team to you, we guys hope that you enjoy your Thanksgiving. It looks quiet on Thanksgiving Day. It just looks chilly. It looks chilly on Black Friday for the Governor's Cup. There's a small shower chance. But we hope that you guys enjoyed this video, gave you a little bit of information, and we hope it gave you a little bit of the backside. Like understanding what goes into these forecasts and not having massive signals, why the statistical probabilities are not as large this winter. Bryce Jones, Rick DeLuca, I'm Chief Meteorologist Mark Weinberg. Follow us if you don't. Share the video.